Alright, so starting out into binomial expansion, we've moved into the main work now. The main thing to do now, we are into it right now. Now, binomial expansion, it just means when you have a binomial and you want to expand it. You see, you must have seen expressions such as x plus y raised to the power of square, and then you have something like x squared plus 2xy then plus y squared, right? Exactly. All of these things were derived out of binomial expansion. And how do we go about it here? Let's move into it. Let's move into the deal. Now, say I have my binomial expansion to be x plus y with a power of, say, b, right? Say my power is b. Yeah. Now, how do you go about this, expanding this math? Now, you start with this. First, you have combination first. B combination. You're starting out with 0. B combination 0 is always the power combination 0 starting out first. Please take note of that. Then multiply by your first term here, which is x, raised to the power, which is b, then minus this part, this 0, which is your r, right? Then multiply by, this is just like the theorem I'm giving you that will guide you as you move on. Alright? So multiplied by your next term, which is plus y, raised to what? Raised to your r, which is 0 here. Right? Alright. Then add, addition is what you do next. So you can simply just break this down as first you have combination, then you have the first term, then you have the second term, and then you add. So we can have this as this. Just follow this. Combination first, then followed by the first term raised to the what? Raised to the power. Let's do this. The first term raised to the power minus what you have as your r. Take note. Your second term raised to your r directly. Right? Do you get that? So that's basically this. Please take note of this. You can write this out somewhere so it guides you as you move on. So following this, we have combination. So moving on, it will be b combination. After 0, we move into 1. Right? This, our new r will become 1 multiplied by x raised to the power of b minus 1. Right? What's happening for first term? It is b. That's what? That's b minus what? Minus r, which is 1 here. Then multiply by your second term, which is what? Plus y raised to the what? Raised to the power of r, which is 1. Right? Then add again. Then move to b combination 2. After 1 gives 2, right? Multiplied by x raised to the power of b minus 2. Multiplied by the second term, which is plus y raised to the power of what? Of your r, which is 2. And this moves on and on and on and on and on and on and on like that. Yeah, you have an infinite. We can continue this forever. Yeah, because this is not a definite power, right? Exactly. So this particular thing is what we will follow as we solve questions on binomial expansion. Let's try to put a power into this. Now we have, say I have, please do well to jot as you watch this video. Thank you. Alright, so say I have a known power here. B is replaced to be 2. Okay? Now we can use 2 methods to this. Doing the binomial expansion using the combination method or using our Pascal's triangle. Let's start out with using the combination method. The first thing you do here is what? Your power combination 0. First thing first, combination multiplied by your first term raised to your power minus what? Minus 0. That's b minus r. Remember, then multiply by plus y raised to the what? Raised to your r, which is 0, right? Then add, what happens next? 2 combination 1 multiplied by what? By x raised to the power of 2 minus 1, right? Multiplied by your second term, which is plus y raised to what? Raised to your r, which is 1. Add 2 combination 2 multiplied by x raised to the power of 2 minus 2 multiplied by plus y raised to what? To your r, which is 2 here. Now when you get to this point where this adds up, what is adding up? Now when you get to that point where the powers are adding up to give 0 until n, that means that is the point where you have to stop. Sorry, where the power are adding up to give your initial power. When you get to that point where the powers are adding up to give your initial power, you have to stop there. What do I mean? 2 minus 2 here will give us 0. 0 add 2 is giving us 2 back. So, which means you can't exit this position. You can't have something like 2 combination 3, then multiplied by x, 2 minus 3, multiplied by plus y, raised to the power of 3. This is wrong. This is incorrect. So you stop at that point where your powers adds up to your initial power. Please take note of this. Very critical. Please. Alright. So we have this. So it's a simple logic. It's a simple logic. As your first term is reducing by your r, the second term is increasing by that r. As your first term is reducing by that r, your second term is increasing by that what? By that r. It's a simple logic, okay? Yeah. So moving on here, 2 combination 0. Alright, from our knowledge of combination, that's 2 factorial, but 2 minus 0 factorial is 0 factorial. Right? Alright, so here we have 2 factorial, which is 2 times 1, or 2 factorial, sorry, over 2 minus 0 factorial, 0 factorial. This crosses out. Here you have 1 as your result. Take note of that. Anything combination 0 gives 1. It's a known thing. Alright, so this gives 1 multiplied by x. 2 minus 0 gives 2. Okay? Multiplied by plus y raised to the power of 0. Anything raised to the power of 0 gives 1. I'm using these dots to represent multiplication so you don't get confused with your x and multiplication sign. Okay? Then add 2 combination 1 gives us 2. Yes, gives us 2. You can do that. That gives 2 multiplied by x raised to the power of 2. 2 minus 1 indices. That gives what? That gives 1. Multiply plus 1 raised to the power of 1 gives what? Gives y. Right? Right? Or let's say plus y. Let's see add that plus y. Okay? Now plus 2 combination 2 gives 1 multiplied by x. 2 raised to the power of 2 minus 2 gives 0. Then multiplied by plus y squared. All squared, right? Here we have that. Now 1 times x squared gives x squared. X squared times 1 gives x squared. Then we have this plus 2 x raised to the power of 1 gives x, right? So x times plus 2 gives plus 2. Plus 2 times plus y gives plus 2xy. Remember, plus times plus gives plus, and 2x times y gives 2xy, right? Same thing happens here. This becomes x squared is what? X squared is 1. 1 times plus 1 gives plus 1. Plus y squared still gives us plus y squared. This is plus y squared. It means plus times plus. Abi, right? Plus times plus is what? Is plus. Then you have your what? Your y squared. This still gives us y squared. So plus y squared multiplied by plus 1 gives us what? Plus y squared. And this results to the initial answer we had before, if you could remember, right? Yes. Please take a look at this, pause and go through the video again so you get it properly.